What's up, everybody? Thank you for being here once more again. Now, today we're gonna continue working on integrating API of same functionalities with different implementations. I know some of you may be asking a question. Why don't you just use the API the way it is built and start integrating that in your application? I could proceed that way, integrating the API as it is without trying to modify. But you gotta accept that I'm a little bit of perfectionist, meaning that sometimes I want things to get done the right way. Now, it doesn't mean that I always do things the right way, but sometimes I think a little bit getting things to be correct. Why not using something that should be the way it's supposed to be? Okay. Now, today we're gonna resume working on integrating these API. One of the API that I've spent most of my time was the mobile service API called M-Pesa. It's actually built by the company name Vodafone. For some of you who live in England or those who live in Ghana, for those of you who live in the country like DRC, it's called Vodacom. So I'm gonna work on the way we can integrate that so we can facilitate payments via a mobile phone. Okay, now let's continue working on that. Previously, we've shown the basic design of integrating the respective APIs from different services so we can facilitate payments. We saw some of the service like the M-Pesa, the Airtel Money, and I started working on the M-Pesa because the M-Pesa was simple to be integrated. So I show you how to get a token which will facilitate making a request to the endpoints that allow the user to make a payment. Today we're gonna continue working on the M-Pesa. I'm gonna go back on our backend where we were working on. So far, as you can see, I have renamed some of the method, like the encrypt client ID, which consists of setting the token. We also have the encrypt session key. It turns out that the client's ID and the session key term are two different data that need to be used to make a request. Usually the request is made with the authorization header sending the encrypt session key, and the session key is retrieved from using both the API key and the public key. So you have a public key, the API key, you encrypt your API key using a signed public key. Okay. Now we need to make some payments today. We're gonna try the way a customer will make a payment to a business to buy a service using M-Pesa payments. To do that, we have to go to make a payment. But before we make a payment, let's look at what M-Pesa recommend before making a payment. Okay, to make a payment, as you can see right here, it says customer to business. So a customer to business, meaning that a customer has to buy something or to buy a item or a service. So what does M-Pesa says about customer to business? You have to send a payload, a type of payload, to a specific URL, and that URL will be, when you are on production, the URL will be the https openapi.mpesa.com/openapi/IPG. This will be the fully qualified URL that you need to use, or you can use the sandbox URL if you are testing. So for the sake of this video, we are testing, so we'll be using the sandbox URL API. This is the one we'll be using. And what does it say? It said that you have to send this field, the input amount, customer MSI SIDN, which means this is the phone number of the customer, the input country, the input currency, the input service provider code, which is the short code of the organization where fund will be credited to, meaning your business. We have the input transaction reference, the customer transaction reference, and that should be unique depending on your client's application. So these are the fields that we need to send in our payload using post on this URL. But we need something. We need to send the authorization token, which is gonna be the encrypt session key. Remember, for us to get a token, we needed to use both the API key and the public key. So to get the token, we wanted to use the public key to encrypt the API key and return the token. But in this case, they say, hey, or to get the session key, as you can see, the granularity of encrypting those information, so everything is kind of linked together. You need the API key, you need the public key, and you use the public key to encrypt the API key, which you're gonna return the session key. And then you're gonna encrypt the session key using the public key to get the encrypt session key that we'll be using to make a payment, so that the customer can make a payment. For the sake of this video, I'm just gonna demonstrate how you can make a payment. But in production, you just don't wanna allow the user to make a payment just in the snap of fingers. It may be done if you want it, but in production, it's recommended to get the KYC of a customer, which is a financial compliance of which stands for Know Your Customer. You have to take the first name, you have to take the last name, you have to take the phone number, some of the basic records before allowing them to make a payment. We're not going to demonstrate that here, but we just want to demonstrate the way we can make a payment. Okay. Now let's encrypt our session key. We already have the way we can get the session key. We get the session key by encrypting the client's ID or the API key. API key or client's ID is the same thing. Okay. In our previous video, we showed the way we could encrypt the client's ID so we can get the session key. In this video, we're gonna encrypt the session key so we can use them to make a payment. Now let's go create, actually this one's supposed to be a session key, okay? Because when we encrypt the client's ID using the public key right here, using the public key right here, we get the session key. And when we encrypt the session key, we get the encrypt session key that will be used to make a payment. Now let's get encrypt session key. I mean, this one will return a none because we're not gonna retain any value. The value will be assigned to a different attribute. Okay, now let's go look at our NFS. By the way, I want to show something we need to modify quickly because things are changing. So we are back on our design so we can review what we were doing and update our design as supposed to. To update our design, things has changed. As you can see, the NFS is no longer named authorization. We name our NFS to mobile payment, and we have the client's ID and the token, which are universal properties that each subclass has to implement or inherit from the abstract class. On M-Pesa, we have the API key, and we have the session key. We also have, as it turns out, we also have the encrypt. I mean, we could alternate the token to receive both the session key or the encrypted key, but I think the session key is separate from the token. So we have the API key, we have the session key, and we also have the public key. Public key, and that's for a mobile service or the mobile financial service, as they call it, the MFS mobile financial service. We have the public key, we have the API key, the session key. That's for M-Pesa. For Airtel Money, we have this client's secrets, and we have the client's ID. This one has to be removed. The API key is the client's ID. Okay, the client's ID or the API key are the same. I don't, even if they're using different concepts, but when we are integrating, we can also merge terminology as we are integrating that. Yeah, now let's go make some payments on M-Pesa. We need to make some payments. Okay, so to do that, we are going to encrypt the session key. So to encrypt the session key, we already have the session key. We are going to use a URL, a specific URL to encrypt the session key. What is the URL we need to use? The URL we are going to use, it's gonna be this URL. Let me show you the URL we need to use. To encrypt the session key, we're gonna use this URL. Let's go to the API documentation, generate session key. Okay, so this is the API, this is the URL that we need to use to encrypt the session key. And you can see we have to replace the markets to the markets where our application has been created, and they have different market options here: Tanzania, Ghana, Lesotho, and this beautiful country here, this country, and of course Mozambique. We have to, let's go back and try to encrypt the session key quickly before we run out of time. So the URL we'll be using is the URL, the sandbox IPG. So let's pass our URL https open API dot mpesa.com/sandbox/IPG/v2. Now the markets, we need to replace the markets. The market's gonna be the country where the application has been registered, and our markets will be Vodacom DRC get session / that will be our URL. Now we need to issue the HTTP request. My clients of choice, I'm going to import the HTTPS, which is the request wrapper. It's built on top of the request module from Python that can be used as a client's HTTP to issue request. Okay. With HTTPX clients, we need to build clients. We are using the Python context manager. For those of you who do not know the Python context manager, it's just a syntactic sugar or an idiomatic way of using the try and catch, which facilitates for your piece of code to fail gracefully. Okay, so with httpx.client as client, we have to create our response client get. We are going to get the URL, the header. We need to pass on the header. We have to pass the token. Actually, this one is the token self. Okay, so the header is gonna be, we already have our header as a default header. We have our default header right here. Content type, the content type in this case, I know the content type, it's a little bit complicated to know if the content type is representational or the content type define what you'll be expecting from the server. We really don't know. But in this case, I think you cannot send a text and expect the XML, or you cannot send a file, expect a text. It might be possible, but the content type in this case is a representational or header, just telling the application, hey, I'm gonna send you the JSON. But at the same time, it's also expecting a JSON response, right? You cannot say the content type application JSON and expect XML, unless you are building a secure application where you don't want to know what you'll be expecting. It depends on the implementation. Okay, so we have our headers right here, and then we go down, we're gonna update. If we go right here, we can update our headers, add a new feed in our dictionary. That feed will be authorization. We pass the bearer and we pass the token. And the header will be update self header. That's our token. Now the encrypt session, the result of this response will be our the session key. Okay, so self session key equal to response JSON. Let's see how we're gonna get that. Let's try this. So we have our M-Pesa. Let's encrypt the client's ID and let's try to print the M-Pesa token so we can see if we're gonna get the token right here after encrypting the client's ID. To do that, we can try something like this: share payments M-Pesa. Of course, I'm not gonna use that like a Python script. I'm using that like a Python script here so you can see the way it can be used when I will integrate that in my Django project. It's gonna be couple line within a REST API endpoint or the Django API view. So we're gonna, when the user send the record, we gonna authenticate them, redirect them to our M-Pesa, make sure that they exist, and proceed from there. But for the sake of this video, I'm using a Python script so I can demonstrate what we are getting from creating these methods. What else do we need? So we've created our session. It looks like we can get the token, and then we're gonna use that token here to get the session key. So we create the token using the API key and the public key. We use the public key to encrypt the API key. It return a token. We use the token to get the session key. And now we're gonna encrypt the session key so we can start making payments. So the response, now let's see the way we can get the session key. If we call M-Pesa object and say encrypt session key, we have not encrypted yet, so we're just gonna return the session key right here. We're just gonna return the response right here. And then we print session key. There we go. So we got our session key. This is our session key. And this is the session key we need to encrypt so we can start making payments. Payments between a customer and a business, where a customer buys something. Okay, so we're gonna grab this output session ID. We're gonna grab it. And now we need to encrypt it. We cannot encrypt it as a string. We need to convert that to a byte string. But we are going to encode that using ASCII. We're gonna use ASCII encoding. We're gonna use our famous create bearer token, which allow us to encrypt a string using a public key. So what we're gonna do on the next step, we're gonna update the token. Now the token is now updated. We could name this encrypted session key, but we're just gonna pass it back to the token. Why we're using the token? Because the token is the one we're going to pass on our header, authorization header. Token self create bearer token. What are we gonna pass on the bearer token? Self session key. The results will be, if we, instead of sending, if we want to print the token right here, you will notice that the token will be a byte string. It's not going to be a string, it's going to be a byte string. And when I'm talking about a byte string, it's in the computer science, byte string. It's not like a byting a string. Okay, let's go test that. As you can see, this is our encrypted session key, and this is the new token that we'll be using to make a payment. Okay, now we need to decode that so it can become a string. We're gonna decode that using the UTF-8 or 16, but let's just use 8. The UTF-16 has just more character than the UTF-8, but the commonly used encoding is UTF-8 or ASCII. Now we've encrypted our session. As we can see, if we've encrypted our session, our design has to automatically change. And I know in practice, we don't go back on the design and update design, but when you are working for a serious organization, they have their design updated, maybe bi-weekly or monthly. They don't just leave their design the way it was first conceived or draft. They go back, they check on the design. There are some software engineer whose role consists of just updating the design. Do we have to do that with the agile methodology system of managing projects? We don't. We usually don't go back on the design and update design, but I'm gonna go update my design. We have session key, and we have a new property name, encrypt session key. Get credential, get API was useless. We don't need that. Get token is useful. We need to get token just in case we are somewhere we need to get respective token. I'm gonna talk about the payload payments. We're gonna see where we need to use this payload, because when you're making payments, each payment has a specific payload. What's going on with this guy? I'm gonna delete him. Let's look for composition. Yeah, there we go. Okay, now let's continue quickly. We gotta go back to our backend and see so we are back on our backend. So we've encrypted the session key. What else we gonna do? We are going to make a payment now that we have our token updated after encrypting. Now, what type of payments do we want to make? We want to make a payment from a customer to a business. And if we go to the documentation, there we go. So we have it now. So to make a payment on our sandbox, we are going to make a payment using this URL. This one. Okay, so let's go make a payment at the URL we're gonna use, and these are the fields we need to send in our payload, and we're going to post it on this URL. I want to show you something, and the default one for testing, we can test using this data. But I'm going to show you the way I'm going to change the data record, because this one is for Ghana. Whereas in our case, we have registered the application for DRC. So we have to change this to DRC and also change the currency to USD or CDF. CDF, which stands for a Congo Democratic Franc, right? This is the payload. Let me copy the payload. We are going to use this payload on our payments right here. I'm going to create a dictionary called payload, and I'm going to paste this. Okay, let me go back to the backend so you can see. Okay, as you can see, it's pasted right here. I copy it and I paste it right here. This is going to be our payload. Of course, we need to send a payload somewhere I can still use the HTTPX. I mean, the advantage of HTTPX of a request is that HTTPS has added new features with also new protocol specification, like the implementation of HTTP 2.0 and the way they send file. It's kind of like it's built on top of requests, but they had new features in terms of uploading files and so forth. Client response. We're gonna send our response to, so I think we need to move adding the authorization to a specific this one right here, updating the authorization. We can create a helper name, update headers. Okay, we can name that update headers. This is gonna take the, okay, instead of say set authorization header, that's the way we're gonna name it, and then we're gonna pass the token. And what this does, it just updates the authorization header with the new token. So we are going to call that right here, and the self set authorization header self token. Okay, we create our helper to update the authorization header. We can also call that right here. You might think because I've just updated that, I can just leave that and continue. No, you have to update that every time so you can get the new token. Okay, now in our response, we're gonna use client post. We have to post to a new URL. That URL, it can be defined right here. I'm gonna copy it. Let me go copy the URL. So the URL we need to make a payment will be from, this will be the URL. We just need to change the market. Let's go back. That'll be our URL. And the market where we'll be sending will be to Vodafone DRC. And this is path. This is not a URL. This is a path. We need to pass the domain name and the ports, domain name and everything. The protocol will be HTTPS, of course. The fully qualified. The domain name will be, I'm gonna try. Let me just pass the port. I think the port with HTTPS, the default port is 443. But let me just pass that literally like this, Okay, so we have our URL. We're gonna pass on this URL. The JSON payload will be the payload. The headers will be our self header. Why? Because we just update that right here. And that about it. Let's go try to print response content and see if we have make the payment. So encrypt session key and M-Pesa make a payment. We need to send the amount. We can set the amounts right here to the amounts. Okay, that's the amount we need to send. Now we're gonna send Let's try, instead of Ghana, because we are on the context of this market, let's try DRC, and we're gonna try USD, or we're gonna try the CDF. And the customer MSI SDN is the customer phone number. The default one for the testing purpose is 000001. And let's try again. Oh, we're not making payments. Let's try to make a payment. M-Pesa, make a payment. If we run it, we can see that we have made a payment. Of course, it's a duplicate transaction because I have tried it before. So if I can change the key right here, I also change the client's reference transaction. Request has been successfully processed, meaning that we've made a payment. The user or the clients, the customer were able to make a payment. He was able to make a payment, or they were able to make a payment. Okay? And that's the way we can try the customer to a business payment using the mobile service named M-Pesa. Now, of course, we don't have to use all this payload because we have different type of payload. We have a payload to check the customer KYC, know your customer. We have a specific payload to check or to refund. If you want to refund the customer, you're going to send a different payload. Airtel Money has a specification in terms of which type of payload you need to send to make a payment. M-Pesa has its own specification, or Afrimani has also his specific way of sending payments from a customer to business. We want to make this to be dynamic. We're going to create different classes where we're going to specify, we're going to record the payload, as I mentioned on my design. As you can see on my design right here, we have a payload, and the payload will be in the method payments. It's just going to be a field, right? It's going to be a payload. It's just going to be a field, or we can name that a templates payments method, where we are going to hash the specific payload as a string, right? Using a cryptographic system like a Blake 2 or any HMark cryptography. I mean, Blake 2 is faster to be to encrypting a byte to hexadecimal digest. So we can use any specific encryption, so we can make a payload as a field, as a template. I know this is a little bit advanced, but I'll get there. I'll show you how we're going to allow the customer to register or to save the payments method. By registering their payment method, we need first to confirm who they are, meaning that if the customer want to register a new payment method, they're going to insert their phone number. When they insert their phone number, we're going to use the phone number to get the KYC, the know your customer credential. If someone want to make a payment using somebody else's phone number, we are going to detect that, because when they insert their phone number, we get the record and we compare the name on that particular SIM card to the person that trying to authenticate themselves. If the name match, we may confirm that the person trying to make a payment is really what they claim they are. We save the record, and we're not gonna save the record. We're not gonna save the templates, this payload right here. We're not gonna save it as an object. We're gonna save it as a hexadecimal string, or hexadecimal hash, right? And then it's gonna be encrypted. You know, I know this is a lot, but trust me, this is the hard part. As it has been already said, do the hard part first, and then whatever is easy, you can just, you know, do it later. So we're gonna proceed with the hard part first, and then we're gonna do the easy part. I'm gonna end this video right here. We were able to make a payment, but this payload you are seeing here, it's not gonna be, we're not gonna use it this way. We're gonna call it using a payment method. So if a user wanna make a payment, they have to select the pre-save. Yeah, they have to select the pre-save payment method, whether they're gonna use a credit card, they wanna use a M-Pesa, or they're gonna use whatever they wanna use, they can save that, you know. And once it's served, it can be selected, and then instantaneously they're gonna make a payment. Okay, that's all for today. Thank you for watching. I'll see you in the next one. Bye bye.